So septic systems are commonly used in low-density housing areas, but the impact on aquifers may be of concern. Map the areas in Austin where census tract population densities are less than 1,000 people per square mile, and where the geologic names of the units contain limestone, terrace, or alluvium. I remember I started demoing this last one, and we ran into some issues, and I did not go back to solve it, so we'll see how we do here. What was it that we did wrong last time with that choosing the right geologic units? You guys remember? We had to use that like. Maybe we'll get to it. So we're going to use, basically the setup between this is we want only those areas that are the population density, that are low density, and then only those areas that have the geologic units of limestone, terrace, or alluvium somewhere in the name of them, such that any of those three are ones, geologic types, where water can move through them really easily. Terraces are that way, alluvium's that way, and limestone, because of caves, is that way. So that's the logic behind this one. And low population areas are areas that are less likely to be connected to town sanitary systems, or more likely to have a septic system. So this one's convoluted, but that's what she's talking about. Okay, so start a new map. This will be EX6. And back to add data, we want the administrative, we want the tracks again, same layer as last time. And then in this case, we want the geologic units. So we've got polygons and polygons. There's probably an environment, and then geology. So let's start off simply with the tracks. She wants anything where the population density are less than 1,000 per square mile. Now, when we look at the attributes for the tracks, if we already have a population density, we can just simply, so we have pop 14 per square mile and pop 10 square mile. You guys have a preference which we run. It's not going to be that different, but no preference. Let's just continue to go with pop 2010, even if she did the other one. So we just want any of these pop 2010 ones with it being less than 1,000. So this is just a simple select by attribute. So here, of all the tracks, a new selection where the pop 2010 per square mile is less than, and then we just type in 1,000. We hit apply on this one, and we end up with 56 of the 262 tracks meet that condition of being low population density, lower than 1,000. What I like to do with this is make a new GIS layer out of it. So I right-click on to lock this selection in. Right-click on it. You can go to Selection and then go to Make a Layer from Selected Feature. We can turn off all the tracks and retain just those tracks that meet that condition. I'm going to rename it from Selection to Tracks. Rename it to less than 1,000 per mile. Okay, so I'll remember that for later. So we can put that on hold for now. Now we need to, this is the tricky one that got me last time, is all those geologic units. So let's take a look at the geologic layer. It's these polygons, and some of these polygons have the word terrace in the name, some have the word limestone in the name, and some have the word, what was it again? A terrace, alluvium was the last one. So let's just, maybe we could just take these one at a time and try to, instead of building an equation, we can just say add to selection each time. So let's just see if we can find all the limestone ones. So again, we're going to set this up as a select by attribute. Oh, it still remembers what I did last time. Kind of. So unit name, and then contains the text. And then let's just do limestone and hit apply. Let's see if some of these select. I don't see anything turned in blue, so something's going wrong here. Still has 0, so what do I need to do? I don't know if I need to put wildcards around this or not. This is weird. Let's see. No, it's got the wildcards. Like, unit name like limestone with the wildcards. Weird. Is it that it's not capitalized? Let's see. Yeah, that one, it is. Let's just... Oh, my goodness, it's case sensitive. So once I put a capital L for limestone, it made that selection. So 292 of those polygons came out to be selected when I used the word limestone. Let's just look down this list to see if there's a terrace in here and see if that's capital letter or... Oh, there's some terrace deposit that's capital again. So then what I can do, guys, is instead of going to new selection here, I can say add to the current selection as the second choice. Unit name contains the text, and then put in terrace. Now all my 292 should remain selected. Now it should also pick up like this record number 8, this 18 here. If I hit apply here, and it did, it picked up those terrace ones. So now I'm up to 388. And the last one it wants is alluvium, and I wonder, just trying to figure out if it's just alluvium lowercase in this case, and it's just one category here. It looks to be alluvium. So I want to make sure and say add to the current selection because I don't want to lose the selection I already have. I'm going to switch this out to be alluvium. And then hit apply. Again, double checking here because if I did a new selection, it'll unselect everything I just did and replace it with just the alluvium one. So we should see the number go up from 388. And now the alluvium got selected, plus the limestone, plus the terrace are all selected. So let's take a look at the resultant map. Here's the polygons that are selected based on our triple query. Again, I'll right click on this, go to selection, go to make a layer from selected feature. And I'm not going to bother changing that. We all know what it is, but you could change the name to those, only those geologic units that meet one of those 3 criteria. So the last step for this is, do we need to have a intersect or a union to get the results that we want? So basically, we want a map that shows any overlap between areas that are low population and have one of these geologic types that are highly permeable. And so in my mind, we don't need to keep all the polygons. We don't need the Venn diagram of all overlapping everything. We only want those places where the two coincide with each other, and then get rid of all the peripheral stuff. So if they meet both of those conditions is what we want from this. And if that's the case, then the intersect tool is preferable to the union. So if that's the case, we go to the analysis, tools, and then type in intersect. And we come up with the intersect tool here. We want to add, our first one is the geologic selection. The second one is our tracts with less than 1,000 people as our 2 features. And then we want the output from this to be something along the lines of, I'm just going to put it to the answer of question 6. It says basically, do we want all those attributes included? If we want all of them, that's fine. Or else we could minimize this. It's not going to make much of this. We just want the map anyways, but it keeps the table. And then the output type, you can specify whether you want it points, lines, or polygons. The default is the same as input. We definitely want this to be polygons as our output from this. So hit run. Hopefully, we'll see only those areas that overlap between the 2 of them as the result of this. Let me just change this to a more unique color. So let's just take a quick look. Geology selection, and then tracts less than 1,000. So we're looking for just those areas that overlap between the 2 of them. So we should see some polygons that are resulting right in this area, and then a bunch that are resulting in this area. A lot of it there, with some kind of these snaky features taken out. So let's take a look at our orange area to see, and that's exactly what we were expecting from that. If we look at her correct textbook answer for that one, that looks like a very similar map to that. So basically this was a kind of a two-part attribute selection to just get those polygons of interest, and then a simple intersect between the two to get the right map. Okay, so that was number 6. Questions about number 6? Okay, all right. Number 7, the clay fraction of soils as well as the road use may affect the frequency of street repairs. So the idea is that soils that are high in clay probably are softer and may result in more damage, but also the number of cars that are traveling on those roads. The more cars, the more damage. And so how many street miles in Austin have more than 50% clay and a road class of 5 or less? Capture a map showing these roads. So we can anticipate off the bat that the output from this is, unlike the last one, the output from this is going to be a GIS layer of roads, and those roads are not going to be polygons, they're going to be lines. So this is going to be a GIS layer showing which lines meet the criteria of being a road class of 5 or more, so get rid of all the rest of the streets and roads, only the high traveled ones, and then a road class of 5 or less, and then only on those areas where the clay content is 50% clay or more. New map. This is going to be question number 7. So we need a GIS layer showing the roads, and we need one showing the clay type. So let's get the transportation. We need to find a layer that has the right attribute. I added the arteries first. Let's just see if that one has a road class. Might be the streets layer instead. Open the attribute table for that one. Road class, there it is. So it's the streets layers, not the arteries that we want. And we want only those road types that are less than 5. Let's see, is that what it said? Less than or equal to, let's see. Yeah, less than. 5 or less. 5 or less, including 5. Okay, so, and then we want something to do with soil. So environment probably, and then there's a soils layer here. And in this one, we hope to see an attribute in the attribute table that has to do with clay. And there's a column called clay, and it looks like I don't see anything going over 100. So it's probably, that's the clay fraction of those soils. So 2 queries again, and then intersect to show only those street segments between that meet both conditions. So let's start off with the streets. If we go to select by attributes, we want a new selection on streets where the road class is less than or equal to 5. Please let me know if you agree. Right, I got that right? Okay, thank you. I'll hit apply on that one. Right now I have the attributes right now for the soils. So this is the case. We have 6,698 street segments out of the 40,000 that are selected that are all road class 5 or less. I like to do that same thing, selection, create a layer from selected features, street selection 5 or less. And then of the soil types, we want to have a selection made on this one by attributes. And guys, I'll finish this demo. If you want to stick around to see the rest of it, stick around. Otherwise, I'll record the rest of this and post this so you can see it. But I'll continue. You guys have a good rest of your afternoon. We'll see you Wednesday. For this one, we're going to do clay is, let's look at it one more time. More than 50% clay. So we want is greater than, and then I'll type in 50. Oh, yeah, it's actually, yeah, it's expressed in percent already, yeah, so thank you. Clay Click OK on that one. Let's go to soils. That gives us only 3 polygons that are 50% or more. Let's just see if that's true. It's only 3 of them. There's a bunch of 49.9s, but just 3 of them meet the condition of over 50% clay. Again, here I'm going to right click on this. Selection, create feature from selected features. There's our over 50% clay. So we want to intersect between those polygons that have soils over 50 and just those roads over and streets over or class 5 or less. So we could do, at this point, we could do a simple clip also would work. It would result in the exact same thing. The only difference between a clip and the intersect is that the intersect, all the attributes get brought along from both. So the geologic type gets written on the attribute table of the streets. If you do a clip, you don't get those attributes. That's the only difference, but the geometry of these two would stay the same. So for this, we will, since it's, the request is to make use the tools of Chapter 10, we will do analysis, toolbox. All right, see you later, Abby. And then intersect again. And in this case, we want the streets selection 5 or less, and then the soil selection, which we mean to be soils with greater than 50%. I'm just going to leave that name, streets, intersect, all attributes, and then the output type for this. If we use same as input, I think it's still going to result in lines. It'll be the lesser of the two. If we wanted to make sure that it's lines, we could always pull that down. But you see the only 2 choices are lines or points. So let's just say same as input, and it should result in lines. If this works, we should only have those streets that meet both criteria. We turn off all these layers. Indeed, that's what we see, are only those streets that are falling inside of there. Again, that looks a lot like a clip, but with the attributes will have all been included. Let's just look at our answer. Oh, wait. Oh, yeah, she wanted numbers, didn't she? And that's why we really need, there are 118.7 miles of roads in Austin with road class 5 or less in place fractions. So we just need to run a summary on the attribute table of the output from this. Let's see if there's already, to get this right, we really need to compute a new field. We can use the shape length on here. That's going to be in units of feet, but we want a new column added onto this of distance in miles. Even if you see a miles one in there, be suspicious because some of those lines might have gotten truncated and the attributes won't have updated. So if it lopped off half of a road segment, it'll still show the length of the whole road segment. So we need to make our own. So I'm going to call this one length. And then I'll just put INT for after the intersect, and then in miles, I'm going to make this one also a float, and then I'll hit save and close out the fields. And then I need to populate this one. Oh my gosh, there's a lot of attributes in there. I need to find the one I just made. Oh, it's very at the end. Calculate field. And I'm going to use shape length. That's going to be important to use because that one does update after you do the truncations on it. So shape length divided by 5280. Did not type that in. Okay, 5280. Here we go. And then she wants capture a map showing the results. How many street miles have, okay, how many miles? So basically, oh wait. So then we just run stats on this. We want the sum. Sum is 118.7. So that seems similar to what she got. Yeah. So that was the right way to do it. And then the map of it, you could show this in various ways, but you know, some kind of a capture that way. Let's see what she turned in. Huh. Streets, clay. does she want? How many street miles? Capture a map showing these roads. She showed a very different map than I was expecting. I guess it's just these highlighted in pink ones are the ones, and those were the same roads that we got. That showed up in green. So that's number 7 as it is. But there's that critical step with number 7 is just to make sure that you're computing the new miles column based on shape length, because that's a really important distinction when you run these either clip, union, intersect, that if there's any other field in the streets layer that isn't dynamically updated, it still could have, if there's any kind of a miles road length per each, it doesn't look like there is, so. But just keep in mind that it would still reflect the pre-clip or the pre-intersect length. And the only one that dynamically updates is the one that's called shape length. And that one does dynamically update. It's in the units of the map projection, feet, divide by 5280 to get it to miles. So that's that. So I'm going to hit